Hey guys, in this video we'll be covering Unit 2.2 of the GP Mathematics Analysis and Approaches course, which is the concept of a function. So what is a function? Well, a function is basically a relationship between two sets of data. Between two sets of data. And what does that exactly mean? Well, imagine you had this two sets of data, okay? So you have this one here and this one here. And you know the values for this set. You know that for this set of data, you have 1, 2, 3, and minus 1. But you don't know any values of data for this set. However, what you do know is that the relationship between the two sets of data will be a function. And let's say this function is f of x equals x squared plus 1. Okay, let's move this down a bit. In this relationship, this set of data here, the one where you know the values, is called the input. And this is usually your x value. While the other set of data is your output, or your f of x, or your y value. F of x and y is basically the same thing. So when you have this function here, f of x equals x squared plus 1, this value would be your output. While this here is your input. And what does this mean exactly? Well, you know that your outputs for this set of data are 1, 2, 3, and minus 1. So let's put them into the function. So first you have f of x equals 1 squared plus 1, which equals 2. So the function of 1 equals 2. So when your input is 1, your output is 2. And then you do it again for the other values. So when your input is 2, your output would be 2 squared plus 1. Your output would be 5. So when your input is 2, the output is 5. When the input is 3, the output is 10. And when the input is minus 1, the output is minus 1 squared, which is 1 plus 1, so 2. And here you'll realize the main feature of a function, and that is each input value only has one output value. So the function of 1 will only give you one answer. Function of 2 will only give you one answer. Function of 3 will only give you one answer. However, you may get the same answer more than once. So when we did function of 1, we got 2. So the function of 1 is 2. However, the function of minus 1 is also 2. So these two inputs have the same output. However, an input cannot have more than one output. The output can be repeated, but the input cannot be repeated. And that is the main feature of a function. So now you have your inputs, right? So your inputs are minus 1, 1, 2, and 3. And you also have your outputs, which are 2, 5, and 10. Now, how would you talk about inputs and outputs using mathematical language? Well, you wouldn't see a question that says f of x has the inputs 1, 2, and 3. You'd see questions which say f of x has the domain 1, 2, and 3. So your domain is basically all the set of inputs you have for a function. So for this question, your domain is your inputs. So your domain is just minus 1, 1, 2, and 3. And the same thing goes for range. Your range is the range of results or the range of outputs you get for the function. So your range for this function is 2, 5, and 10. Okay, so your current domain is minus 1, 1, 2, and 3, right? But let's say you wanted to expand this domain. Let's say you wanted to find more outputs, meaning you wanted to have more inputs. And let's say you want your new domain to be every single number between -1 and 3. So you want -1, you want to find the output of 0.5, minus 0.2, 0.11111, all infinite numbers between -1 and 3. How would you write this down? Well, you would say that the domain is every single number between -1 and 1 and 3, sorry, right? So all x values between -1 and 3. If you want -1 and 3 included in the domain, you would put greater than or equal to -1 and 3. So -1, 2, 3, including those two numbers. And now if you change your domain, your range will obviously change because now you've got infinite numbers between these two numbers. And so you'll obviously have a lot more outputs. And what would your new range be? Well, you would first find the lowest value you can get using this function, which would be when x equals 0, y would be 1. So the function of 0 is 1. It will be equals to 1, y. And then you put the largest output you can get between 1 and 3. And this would be when x equals 3. So 3 squared plus 1 is 10. So the largest output you can get is 10. So your range is now 1 to 10. So now you have your domain, you have your range, and you have your function, which is f of x equals x squared plus 1. And you want to display this data, you want to display this relationship in a visual manner, because it's always easy to understand data if you can see it visually, if there's a graphical representation. And how would you do this? Well, you draw it in the form of a graph. And what does a graph look like? Well, you're probably familiar with the Cartesian plane, which is the xy coordinate system. So you have these xy planes, and this is your x coordinates, these are your y coordinates. This is y equals 1, y equals 2, y equals 3, x equals 1, 2, 3, minus 1, minus 2, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, and so on. So you're probably already familiar with this form of representation, the graphs. So now what you do is you take your data and you put it into the graph. You know the domain is -1 to 3. So first, you want to find what the output is when x equals -1. So when x equals -1, you know that y equals 2. So here you put a value at x equals -1, y equals 2. Then you want to see what another input is and find the output. So let's say your input is 0, your output is 1. When your input is 1, your output is 2, and so on. And you want to find the value for the smallest output, for the smallest input and the largest input. So your largest input is 3, your largest output will be like 10. And now you gotta draw the graph. And this is basically just connecting the dots here. So your graph will look something like this. With the domain, let's say that this point here is at 10. So y equals 10. You can see that's your range. Let's move this graph down a bit. Your range is all the y values you have. And as we stated earlier, the range for this function is 1 to 10. And you can see this here where the smallest value is 1. So smallest value is at 1 and the largest value is at 10. And your domain is -1 to 3, right? So your smallest value is at -1, largest value is at 3. And this is how you display a function in a graphical manner. And now if you go back to the very start, you remember we said we have two sets of data, right? Your inputs and your outputs. And all of what we just did was assuming that you're given some inputs and you have to find the outputs. But what if it's the opposite? What if you're given the outputs and you have to find the inputs? Let's fix that. There we go. So we know that our outputs for this function are 2, 5, and 10, right? It's these values here. But we want to know what the inputs are. One way we could do this is to find the inverse function of x. And you learn how to find this equation in 2.5. For now, I'll just tell you that the inverse of this equation is root x minus 1. You'll have to trust me on this one. So when this becomes a new equation, inverses of f, these values, so these output values that are here, then become the new inputs of this new equation. So if we draw our new sets of data, here and here, before these were the outputs, these are the inputs. Now these are the inputs, and these are the outputs. And your inputs to root x minus 1 is 2, 5, and 10. Your new inputs are your y values. And so let's find f minus 1 of 2. So when y equals 2, what is x? X is 2 root of 2 minus 1. X is plus or minus 1. So your new output is plus or minus 1. And if you keep doing it, you get plus or minus 2, plus or minus 3, etc., etc. Okay, so now you have values for this set of data, this set of data, this set of data, and you just have this one left, right? So what do you put in here? Well, if you know that these are the outputs from your original function, then these are the inputs from your original function too, right? So this would be plus or minus 1, plus or minus 2, plus or minus 3, etc. And now, let me real quick just, let me just quickly switch around the places of these two. So if these are your original inputs of f of x, and these are your outputs of f of x, these are your inputs of f of inverse of x, these are your outputs of f of inverse of x, what do you notice? Well, the outputs here are the inputs here, the inputs here are the outputs here, right? So what you get is just an endless cycle of this, 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 right? So to get from here to here is f of x. To get from here to here is inverse of x. To get from here to here is f of x again, and then inverse of x. And you see how these two sets of data relate to each other. They're just, the outputs are the inputs, inputs are outputs. And again, you remember that the domain, so the domain is all your x values, and your range is all your y values, right? So here, this is the domain, this is the range. But now in the inverse function of x, your new domain becomes this, and your new range becomes this. So for f of x, right, let's put it in. For f of x, your domain is plus or minus 1, plus or minus 2, plus or minus 3, and your range is 2, 5, 10. For inverse function of x, your domain is 2, 5, and 10. So domain is 2, 5, 10. Range is plus or minus 1, plus or minus 2, plus or minus 3. And what do you notice? Well, the domain of f of x is the range of the inverse function, and the range of f of x is the domain of the inverse function. They just switch around. And if you also remember from what we said at the very start, the one rule of functions is that each input can only have one output, right? However, here we see that when the input is 2, you get 2 outputs. When the input is 5, you get 2 outputs. So what do we do in this scenario? How do we draw the graph? Well, you can't really draw a graph of this function. What you have to do is something called domain restriction. And this is something that you'll learn later on in this topic. And now we'll finish off this video with a nice little question from IB Revision Village. So, the following diagram shows the graph of y equals f of x for the domain -4 to x to 5. First question is to find the value of f of 1. So, question A, part 1, function of 1. And f of 1 is basically when x equals 1. What is the y value? So x equals 1 over here, right? So what you do is draw a nice little straight line through x equals 1. And you see where the graph intercepts this line. And it's here at y equals 3. So function of 1 equals 3. Simple as that. Part 2 is asking for the inverse function of 2. And if you remember, the input for the inverse function is the output of the normal function, right? So this is basically, f of x equals 2. And for what value of x is the height or the y-coordinate 2? Well, what we do this time is we draw a nice little dotted line through y equals 2, and we see where it intercepts the graph, and that is over here at x equals 0. So inverse function of 2 is 0. Simple as that. And now we go to part B, which is find the domain of the inverse function. And if you remember, the range of the normal function is the domain of the inverse, right? So whatever the range of this function is the domain of the inverse. And what is the range of this function? Well, it is the highest y value and the lowest y value. So the range is from the lowest y value is here, -2. So -2 y, and the highest y value is here at 4. So this becomes 4. And if this is the range of f of x, then the domain of the inverse is the same values. So equals -2 x, not y, because now we're talking about domain, to 4. And that's it.